Hello everyone. Today we will be discussing on the topic electricity. In this video we will be discussing about the resistance, the factors on which resistance depends upon. So as usual we are going to discuss it with the help of equation. This question I have taken from class 10th NCERT textbook. Let's read the question first. The resistance of a metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. If the diameter of the wire is 0.3 mm, what will be the resistivity of the metal at that temperature? Using table 12.2, predict the material of the wire. So in this question, what are we given? We are given resistance at a given temperature and we are given diameter. We need to find the resistivity. Before that, let's try to understand about the resistance part. Okay. So what is resistance? What is resistance? So resistance by word itself means it's called opposition. The word itself, meaning of the word itself is opposition, to resist something, to oppose something. So in electricity, what are we going to oppose? So this is the property of the material. Okay, this is a property of the material which shows what? Opposition to the flow of charge, or I can say the current. Charge per unit time is current. So what is resistance? It is a property of the material to show opposition to the flow of charge or current. So every material will have resistance. Say it, you must have studied in lower classes that conductors which allow the current to flow through them, insulators which do not allow the current to flow through them, whether it is insulator or conductor. So this property is omnipresent. So whether it's a conductor or insulator, they are going to show what? Opposition to the flow of charge. But the thing is, some will show less, some will show more. Such a huge value that no current passes through it. That is only the difference. Every material will have its own characteristic nature to oppose it. So what are the factors on which this resistance depends upon? The factors on which this resistance depends upon are: number one, dimensions. What do you mean by dimensions? Dimension means two things. Number one, length of the material. Number two, area of cross section. Number two, area of cross section. Area of cross section. Right? So what do you mean by length? Length is the distance through which the current flows along the conductor. The distance through which the current flows along the conductor. Let me give you one example. For example, I have a cuboidal, let's say I have a cuboidal wire. So wire in the form of a cuboid. Wire in the form of a cuboid I have attached to the circuit. I have attached to a circuit. So here is a battery and we have a key. Right? So the current will flow through this conductor. Right? Will flow through this conductor. So what is the length along which it is covering? What is the length along which it is the current passing through it? That is L here. That is L here. So this is length here in this case. Suppose I take the same materials, everything is same, but I am placing it in the circuit in this manner. Okay. So just forgive that background noises. So I am placing it in this manner and I am connecting it to the same circuit. Now the current is flowing in this direction, and what is the length? This is the length. This is length here. So it is the distance along which the current flows through the conductor. So that is the length. Here the length is this. Here the length is this, because current is flowing only through this length. Only through this length. Here it is flowing through this length. So same material, same conditions, but just I have oriented the conductor like this. So the length has changed. That means the resistance offered by the material has also changed. Next one is what? Area of cross section. What do you mean by area of cross section? Now see there, the area of cross section means the area through which the current flows. Area through which the current flows. What does that mean? In the first case, let's see. So through which area the current is flowing? Current is flowing through this area, right? Current is flowing through this area. So this is area of cross section. In the second case, this is the area through which the current is flowing. So this is area of cross section, which has more area of cross section. Obviously the second case has more area of cross section, which has more length here. Case 1 has more length, case 2 has more area of cross section. So the area through which the conductor passes, the area through which the current passes, not conductor, current passes through a conductor, we'll call it as area of cross section, right? If it is a cylindrical and I have kept like this in the circuit, so what is the area of cross section here? Here the area of a cross section is the circle, right, through which the current is passing. So I'll call this as A. Here this rectangle is the area of cross section. Okay, this big rectangle. Here the small rectangle is the area of cross section. So it depends upon the area of cross section. So you understand what is the area of cross section, how to take it when a given conductor is given to you. And what is the other factor? The other factor is the nature. The other factor is the nature. The second one is the nature of material. As I've already told, every material opposes the current. So every material is formed differently. So according to its nature, it will oppose. Some will oppose less, some will oppose more. Why? What is the reason? You have to see at the molecular level what's happening at the molecular level. So in order to understand this nature, or to give some value which is seen macroscopically, so we have used a constant called resistivity. Resistivity denoted by rho. I am denoting length by small l, area of cross section by small a, and resistivity rho. So this resistivity is because of what? The characteristic property. It completely depends upon how the material is made. You have to see at the molecular level how they are behaving to the flow of current. So this is a characteristic property, and also this property is dependent upon temperature. This property is also dependent upon temperature. That's why you have to take care of the temperature at which we are talking. Okay, we have to take care of the temperature at which we are. So in Ohm's law also, when we deal with it, we will say that the temperature has to be kept constant. If temperature is not kept constant, the resistance will not remain constant. When resistance do not remain constant, V is not proportional to I. So we'll talk the resistivity for only at a given. Suppose if you ask me what is the resistivity of this material, then I'll ask at what temperature you want. So at that temperature I'll tell you the resistivity. Then you can calculate the resistance. So that is it. And moreover, I can tell one more thing, how the resistivity depends upon the temperature. Okay, how the resistivity depends upon the temperature. So resistivity rho, okay, resistivity rho increases with temperature, okay, for conductors, mostly metals. For most conductors it increases with the temperature. For metals it increases with the temperature. So we'll say it as a positive coefficient of temperature. It increases with temperature. More temperature, resistivity more. Suppose I can give one example. Suppose aluminum, if I take one metal like aluminum, if I measure some resistance R at 20 degrees Celsius, for example, same material, same length, same dimensions, area of cross section. If I measure the same thing at suppose 60 degrees Celsius, now I'll not get this R, I'll get slightly more resistance. I'll get more resistance. This both are not equal. R and R dash are not equal, as the temperature is not equal. Obviously R dash is going to be more than R. So the resistivity increases with the temperature for conductors. And what about the insulators and semiconductors? So rho decreases with the temperature. We'll say it as negative coefficient, right? Decreases with temperature. Decreases with the temperature for both semiconductors as well as insulators. Do you know that semiconductors, why they are called semiconductors? Actually they are insulators at room temperature, but as I increase the temperature, they'll act like conductors at higher temperatures. That's why they are called semiconductors. Materials like silicon, germanium, or etc. Semiconductors, they are insulators at room temperature, but as the temperature increases, what happens? Rho decreases. If rho decreases, then what happens? If rho decreases, then the resistance decreases, and these semiconductors, the special quality is that at higher temperature they are acting like conductors, right? So this is the dependence on the resistivity. There is a dependence on the resistivity. While we are talking about resistivity, we have to keep in mind what? The temperature. Now let's get on to the question now. Okay, I didn't explain how they are dependent upon, how the resistance is dependent upon the factors. So for that, what you have to do? You have to do experiments. Dependence of resistance. You have to do what? Experiment. You have to change the length of the material, you have to change the area of cross section of the material, you have to change the material itself, etc, etc. You have to do, okay, dependence. You have to do that, and many scientists have already done, so no need to do, just understand how they are. The resistance is proportional to length. The resistance is proportional to length. If I increase the length, what happens to the resistance? Resistance will also increase. If I decrease the length, what happens? The resistance will decrease. So they are directly proportional. More length, more resistance. Next, the resistance is inversely proportional to area of cross section. That means more area of cross section. This implies that the resistance will be less. More area of cross section, resistance will be less. Less area of cross section, resistance will be more. Just tell me, what do you want? You want more resistance or less resistance? We want the current to flow, right? Flow through the circuit, right? So obviously we want what? Lower resistance. So what is the dependence here? R and A, inversely proportional. So we can write it as R is proportional to L by A, and R is equal to rho L by A at a given temperature. At a given temperature. At temperature, we'll keep it as constant. To get the constant value of resistance, temperature will keep it as constant at a constant value of, to get the constant value of resistance. So this is the dependence. So let's do the question now. What's the question? The question is, let's write the given here in the question. So what's the given in the resistance of the metal wire? Okay, is resistance is given, R is equal to 26 ohms. The resistance of a metal wire of length 1 meter, length is given 1 meter at what is this value? This resistance is at 20 ohms, right? If the diameter of the wire is, how much? 0.33 mm. Okay, diameter of the wire is 0.33 mm. What is the resistivity of the metal at that temperature? So we need to find out rho at 20 degrees Celsius. Alright, now we have to understand what is the shape of the wire. Okay, so wire is generally considered as a cylindrical. Wire is generally considered as cylindrical. So this is the length. How much here in this question? 1 meter. So what is the area of cross section? This is the area of cross section, and the diameter is 0.3 mm. Diameter is 0.3 mm. So what would be the area there? What is the area of cross section? Area of cross section is equal to pi r square, or we can write it as pi d square by 4, pi d square by 4. Okay, and so area is that. So by the formula R is equal to rho L by A, can we find rho? So rho is equal to RA by L, RA by L. So what is the value of R at 20 degrees Celsius? We want it at 20 degrees Celsius. So R at 20 degrees Celsius is how much? 26 ohms. 26 ohms. What is the area? Pi into, what is D square? D is how much? 0.3 mm. So I can write it as 0.3 into 10 power minus 3 meters whole square by 4. By length is how much? 1 meter. So this is what you have to solve it. You have to solve it. Okay, you have to solve this. What we have now? We have as 26 into pi. I'm taking it as 22 by 7. You can take it as 3.4 also, into 0.09 into 10 power minus 6. So you use calculator or use it, do it. So what I'm doing, I'll take only, I don't have calculator now, so I'll just, that was 26 ohms, I'm just making it as 28, so that my calculations will be easy. 7 ones are 7 fours are 4 ones are 4 ones are. So what is the answer? 22 into 0.9. How much is 22 into 0.9? 18, right? 18, 19, 22 into 0.9. So after 2 digits, 1.98 into 10 power minus 6. What is the unit? What is the unit of resistance? Ohm. What is the unit of area? Meter square by meter. So the unit is ohm meter. So the unit is ohm meter. So what is the unit of resistivity? Ohm meter, right? So I have taken the extra value, right? 26, but I have taken here 28 because I am getting approximate value. So the resistance has to be less than this. The resistance has to be less than this. So see the table 12.2, which is just less than 1.98 into 10 power minus 6. So if the resistivity is 10 power minus 6, it is going to be the pure metal. Okay, it is going to be pure metal. If it is 10 power minus 8, it is going to be alloy. If it is a 10 power plus 10 to 10 power plus 16, it is going to be insulator. So it's a pure metal here, pure metal. If you see the table, you'll find that this material is nothing but manganese. This material is nothing but manganese, symbol Mn. Right? I hope you have understood the concept. And if you have any doubts, please write it in the comment section. And I'm linking other videos also to this video, so that you can watch others also, in which I have done about, we have discussed about Ohm's law and many other things which will improve your concept. Bye for now.